A listed connector is a product that has been evaluated and approved by an accredited testing laboratory such as Underwriters Laboratories or the Canadian Standards Association. Listed connectors meet the safety requirements of the applicable electrical codes and are designed to be used with specific types of conductors and applications. Examples of listed connectors that are suitable for grounding applications include threaded grounding connectors. These connectors use bolts or screws to secure multiple conductors together. They can be used for splicing ground wires, connecting ground routes to conductors, or grounding equipment. Split bolts are two-piece connectors that clamp around the conductors and are bolted together. They are commonly used for splicing ground wires. Crimp connectors use a special crimping tool to create a secure connection between conductors. They can be used for splicing ground wires or connecting them to terminals. Mechanical lugs are bolted or clamped to conductors and provide a means of connecting to terminals or other equipment. They can be used for grounding applications or for connecting ground wires to structural components. Mechanical lugs bolted to beam clamps and clamped onto steel beams can be used for terminating equipment grounding conductors for cable tray systems. However, the following conditions must be met. Firstly, the mechanical lug must be listed for use with a specific conductor size and type. Secondly, the beam clamp must be designed to securely hold the grounding conductor and be of sufficient size for the conductor. Thirdly, the connection between the mechanical lug and beam clamp must be made with properly sized and torqued bolts or screws. Fourthly, the entire assembly, including the lug, beam clamp, and conductor, must be securely fastened to the steel beam to ensure a good electrical connection. In the context of electrical systems, grounding serves a crucial role in ensuring safety and proper functionality. Grounding provides a low impedance path for fault currents to return to the source, which helps to trip circuit breakers or fuses and energize the circuit in the event of a fault. This protects people from electric shock and prevents damage to equipment. The National Electrical Code, or NEC, provides comprehensive guidelines and requirements for grounding electrical systems. These requirements cover various aspects of grounding, including the size and type of grounding conductors, the methods of connecting grounding conductors to ground electrodes, and the bonding of metal enclosures and equipment. Proper grounding is essential for compliance with electrical codes and standards. It also helps to minimize electrical noise and interference, improve the reliability of electrical systems, and enhance the overall safety of electrical installations. When selecting connectors for grounding applications, it is important to choose listed connectors that are specifically designed and tested for grounding purposes. Listed connectors are evaluated by accredited testing laboratories to ensure that they meet the applicable safety requirements and performance standards. They are also marked with the listing mark of the testing laboratory, which indicates that they have been certified for use in grounding applications. Using listed connectors provides assurance that the grounding connections are reliable and safe. It also helps to prevent potential problems such as loose connections, corrosion, and overheating, which can compromise the effectiveness of the grounding system. In addition to selecting listed connectors, it is also important to follow the manufacturer's instructions for installation and use. This includes using the correct tools and techniques for making the connections, as well as ensuring that the connections are properly tightened and secured. Proper installation is essential for ensuring that the grounding connections are effective and reliable. When terminating equipment grounding conductors to structural steel, such as beams and columns, it is important to use methods that provide a reliable and low-impedance connection. One common method is to use mechanical lugs bolted to beam clamps. The mechanical lug should be listed for use with a specific conductor size and type, and the beam clamp should be designed to securely hold the grounding conductor and be of sufficient size for the conductor. The connection between the mechanical lug and beam clamp should be made with properly sized and torqued bolts or screws. It is also important to ensure that the entire assembly, including the lug, beam clamp, and conductor, is securely fastened to the steel beam to ensure a good electrical connection. The steel beam itself should be part of the building's grounding system, which means that it should be connected to the grounding electrode system. This can be accomplished by bonding the steel beam to the grounding electrode system with a grounding conductor of the appropriate size and type. The grounding conductor should be connected to the steel beam using a listed connector that is specifically designed for this purpose. Maintaining a low impedance grounding path is crucial for ensuring that fault currents can quickly and safely return to the source. This helps to minimize the voltage rise on metal enclosures and equipment, which reduces the risk of electric shock. It also helps to trip circuit breakers or fuses quickly, which de-energizes the circuit and prevents further damage. To maintain a low impedance grounding path, it is important to use grounding conductors of the appropriate size and type. The size of the grounding conductor should be based on the size of the ungrounded conductors in the circuit, as specified in the NEC. The grounding conductor should also be made of a conductive material, such as copper or aluminum, and it should be protected from corrosion. In addition to using grounding conductors of the appropriate size and type, it is also important to ensure that all grounding connections are clean, tight, and free of corrosion. This can be accomplished by using listed connectors that are specifically designed for grounding purposes, as well as by following the manufacturer's instructions for installation and use. It is also important to periodically inspect grounding connections to ensure that they are in good condition. The NEC requires that electrical systems be grounded in accordance with the requirements of Article 250. This article provides detailed information on the grounding of electrical systems, including the types of grounding systems that are permitted, the methods of connecting grounding conductors to ground electrodes, and the bonding of metal enclosures and equipment. Article 250 also covers the grounding of specific types of equipment, such as generators, transformers, and motors. It is important to carefully review and follow the requirements of Article 250 to ensure that electrical systems are properly grounded. Proper grounding is essential for protecting people from electric shock, preventing damage to equipment, and ensuring the safe and reliable operation of electrical systems. In addition to the requirements of the NEC, there may also be local codes and regulations that apply to grounding electrical systems. It is important to check with the local authorities to determine if there are any additional requirements that must be followed. Local codes and regulations may vary depending on the location, so it is important to be aware of the specific requirements in the area where the electrical system is being installed or modified. Compliance with all applicable codes and regulations is essential for ensuring that electrical systems are safe and code compliant. The use of exothermic welding is another acceptable method for making grounding connections. Exothermic welding, also known as CAD welding, creates a molecular bond between the conductors being joined. This results in a connection that is highly resistant to corrosion and degradation over time, making it a reliable option for grounding applications. The process involves using a special mold to hold the conductors in place and then igniting a powdered metal mixture that melts and fuses the conductors together. Exothermic welds are commonly used for connecting grounding electrodes to grounding conductors, as well as for bonding metal structures and equipment to the grounding system. When using exothermic welding, it is important to follow the manufacturer's instructions carefully and to use the appropriate safety precautions. The process involves high temperatures and potentially hazardous materials, so it is essential to wear appropriate personal protective equipment such as gloves, safety glasses, and a face shield. It is also important to ensure that the area is well ventilated and that there are no flammable materials nearby. Proper training and experience are necessary to perform exothermic welding safely and effectively. Regular inspection and maintenance are crucial for ensuring the continued effectiveness of the grounding system. Grounding connections can loosen or corrode over time, which can compromise the integrity of the grounding path. It is important to periodically inspect all grounding connections to ensure that they are clean, tight, and free of corrosion. Any loose or corroded connection should be repaired or replaced immediately. The grounding electrode system should also be inspected to ensure that it is in good condition and that it is providing a low impedance path to ground. The grounding electrode should be checked for corrosion and damage, and the connections between the grounding electrodes and the grounding conductors should be inspected for tightness and corrosion. In addition to visual inspections, it is also recommended to perform periodic ground impedance testing to verify the effectiveness of the grounding system. Ground impedance testing measures the resistance of the grounding path, which can indicate whether there are any problems with the grounding connections or the grounding electrodes. If the ground impedance is too high, it may be necessary to repair or replace the grounding connections or the grounding electrodes. Grounding is a critical aspect of electrical safety and should not be taken lightly. Proper grounding protects people from electric shock, prevents damage to equipment, and ensures the safe and reliable operation of electrical systems. It is important to follow all applicable codes and regulations, use listed components, and perform regular inspection and maintenance to ensure that the grounding system is effective and reliable. When working on electrical systems, it is always important to energize the circuit before making any connections or repairs. This can be accomplished by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before working on the circuit, it is also important to verify that the circuit is energized by using a voltage tester. This will help to prevent accidental electric shock. In addition to energizing the circuit, it is also important to wear appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. This will help to protect you from electric shock and other hazards. It is also important to work in a well-lit and dry environment. Wet or damp conditions can increase the risk of electric shock. When working on electrical systems, it is always best to consult with a qualified electrician if you are not sure how to proceed. A qualified electrician has the training and experience necessary to perform electrical work safely and effectively. They can also help you to ensure that your electrical system is code compliant and safe. Understanding the principles of grounding is essential for anyone working with electrical systems. Grounding provides a low impedance path for fault currents to return to the source, which helps to trip circuit breakers or fuses and to energize the circuit in the event of a fault. This protects people from electric shock and prevents damage to equipment. Grounding also helps to minimize electrical noise and interference, improve the reliability of electrical systems, and enhance the overall safety of electrical installations. The NEC provides comprehensive guidelines and requirements for grounding electrical systems. These requirements cover various aspects of grounding, including the size and type of grounding conductors, the methods of connecting grounding conductors to ground electrodes, and the bonding of metal enclosures and equipment. It is important to carefully review and follow the requirements of the NEC to ensure that electrical systems are properly grounded. The effectiveness of a grounding system depends on the quality of the connections. Loose, corroded, or improperly made connections can significantly increase the impedance of the grounding path, reducing its ability to safely conduct fault currents. This can lead to higher touch voltages during a fault, increasing the risk of electric shock. Therefore, it's essential to use listed connectors that are specifically designed for grounding and bonding purposes. These connectors have been tested and certified to meet stringent performance standards, ensuring a reliable and low impedance connection. Furthermore, proper installation techniques are crucial. Connections should be made according to the manufacturer's instructions, using the correct tools and torque specifications. Over-tightening or under-tightening can both compromise the integrity of the connection. Regular inspection and maintenance are also vital to ensure that connections remain tight and free of corrosion over time. In addition to the grounding conductor, the grounding electrode system plays a critical role in providing a path to earth for fault currents. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes, that are buried in the earth and connected to the grounding conductor. The grounding electrode system should have a low impedance to earth, which allows fault currents to dissipate quickly and safely. The NEC specifies the requirements for grounding electrode systems, including the types of electrodes that are permitted, the minimum size and depth of the electrodes, and the methods of connecting the electrodes to the grounding conductor. It's crucial to ensure that the grounding electrode system complies with these requirements to provide effective grounding. The function of bonding is to create an electrically conductive path between all metal parts of an electrical system that are likely to become energized during a fault. This includes metal enclosures, raceways, and equipment frames. Bonding ensures that all these metal parts are at the same electrical potential, minimizing the voltage difference between them and reducing the risk of electric shock. The NEC requires that all metal parts of an electrical system be bonded together using bonding conductors of the appropriate size and type. The bonding conductors should be connected to the metal parts using listed connectors that are specifically designed for bonding purposes. Proper bonding is essential for creating a safe and effective electrical system. Cable trays are commonly used to support and route electrical cables in industrial and commercial facilities. When cable trays are used to support equipment grounding conductors, it is important to ensure that the cable trays themselves are properly grounded. This can be accomplished by bonding the cable trays to the building's grounding system using bonding jumpers of the appropriate size and type. The bonding jumpers should be connected to the cable trays using listed connectors that are specifically designed for bonding purposes. It is also important to ensure that the cable trays are mechanically strong enough to support the weight of the cables and the equipment grounding conductors. The cable tray should be installed in accordance with the manufacturer's instructions and the applicable electrical codes. When terminating equipment grounding conductors to structural steel, such as beams and columns, it is important to use methods that provide a reliable and low impedance connection. One common method is to use mechanical lugs bolted to beam clamps. The mechanical lug should be listed for use with the specific conductor size and type, and the beam clamp should be designed to securely hold the grounding conductor and be of sufficient size for the conductor. The connection between the mechanical lug and beam clamp should be made with properly sized and torqued bolts or screws. It is also important to ensure that the entire assembly, including the lug, beam clamp, and conductor, is securely fastened to the steel beam to ensure a good electrical connection. The steel beam itself should be part of the building's grounding system, which means that it should be connected to the grounding electrode system. This can be accomplished by bonding the steel beam to the grounding electrode system with the grounding conductor of the appropriate size and type. The grounding conductor should be connected to the steel beam using a listed connector that is specifically designed for this purpose.